Hello everyone, so today we'll be solving the lead code problem of the day, combinations. We have been given two integers n and k, and we need to return all the possible combination of k numbers chosen from the range n to 1 to n. You may return the answer in any order. So the question definition is very simple. The question is asking us to return all the possible vectors which will be having numbers from range 1 to n, and the numbers will be occurring just one time, and the size of the array should be k, and we need to return the combination of all those arrays. So since the problem has been asked to find out all the possible combinations, the first thing that should come to our mind is that we can use a recursion approach. Why recursion? Because recursion is the only thing that can actually generate all the possible combinations. Another approach is using bitwise operator, but we are not going to discuss this problem using that by using that approach. So we will be discussing this problem by using recursion. So let me use the whiteboard. uh, we have been given a value of n and a value of k, and we need to return vector with size k having elements from range 1 to n. So I hope this question is actually clear. Now we will be drawing the recursion tree, how the recursion is actually happening. We will be visualizing that. So the recursion will be starting from 1. Why 1? Because from 1 we can take the elements, right? I mean 1 and then 2, 1, 3. So we are starting from 1. From 1, in the first problem n is equals to 4 and my k is equals to 2. So my one we will be taking a temporary vector, and when the temporary vector size becomes equals to k, we will push that vector into our final answer, and then we will return from that recursion call, right? So we will be pushing just one from this, and then after one we are gonna travel what are the options. We will be having 2, 3 and 4, so we will be having 2, and then we will be having 3, but we are not gonna call all the recursion call all at once. So let's first draw. So at this point of time the temporary vector size will be equals to 2, that is equals to k, and at that point of time we will push 1 comma 2 in our final vector array, and the call will return from here, and while returning we will simply pop back this element. While popping back this element we will be reaching at 1, and from 1 again we can go to 3. Again the size will become equals to 2, temporary vector size will becomes equals to 2, and we will pop this element and then return back, and 1 comma 3 will be pushed back in the final vector. Similarly we can go to 1 comma 4, and at 1 comma 4 what will be the options? We will be the temporary vector size will be equals to 2, and we are gonna simply push 1 comma 4 in the final vector array, and simply we are gonna trace back. And at 1, now can we push 5? Can we call a recursion stack for 5? No, because the value of n is equals to 4 only, so this recursion call will not be made, and everything will now everything will be popped out. So now the recursion call is empty. Now what? Now a recursion call for 2 will be made, and from 2 3 will be called, again pop back, and then again from 2 4 will be called, again pop back. So 2 and 3 and 2 2 and 3 and 2 and 4 will be added to our final vector. Now what? The recursion call for 2 is again over. Now we will go to 3. From 3 we can go to 4. So 3 and then 4, right? And then again pop back. Then 3 recursion call is over. Then from 4 where can we go? We can go nowhere, because 4, after 4 we can go to 5, but 5 is not present in the but 5 is not present in our range. So my final answer will be this. Now let's see the coding section of this. Yeah, so I have taken a vector of vector answer. This will be storing the final answer of all the small vectors, and this is the temporary vector that will be storing the vector size at each recursion call. And we are now calling the solve function that will be actually carrying out the recursion process, and then finally we are gonna return answer from here. So let's understand what the solve function is actually doing. The base condition is when the temporary or size vector becomes equals to k, we will simply push that temporary size vector into the final vector answer, and then simply return from there. And after that, from where we can go, we will simply go from current element to n, and we will keep on pushing the element, and when the size reaches k, we will simply return, and we will the call will come here, and then the element from the last most element from temp will be popped out, and then size will become one less, and then again recursion call will be made. Similarly, uh, recursion call for other stack spaces will also be made, and this is all about the code. And if you find any issue in solving the problem or understanding the problem, please ask me in the comment section. I will be glad to help you. Thank you.